In this video, we are going to understand what is the Ohm's law. It is one of the simple and one of the first laws that we come across when we study current electricity. And it's a very simple, very common sense type of, not a simple common sense type of a law. The law states that at constant temperature, the current at constant temperature, the current flowing through a conductor is directly proportional to the potential difference across its ends. This is a sign of potential difference, also called voltage. This is what the Ohm's law states. It states that this is a sign of direct proportionality. Basically, not a sign of direct proportionality. It is the sign of proportionality. That's it. And the law states that the current I directly proportional to the potential difference V across its ends. Across ends because within its ends is the place where the current is going to travel. So when you say that the I is directly proportional to V, we can also say that V is directly proportional to I. Now we see that we can also say that V is directly proportional to I. So to cancel the sign of proportionality, we say equal to R into I, where obviously, as you can see, that this R has come in as a proportionality constant. That's how it has come into the equation. It was not there before. We want to convert the proportionality sign equal to the equal to sign. We have to introduce a proportionality constant there, and R is that proportionality constant, which is called resistance. And this is the mathematical equation of the Ohm's law. The mathematical equation, yes. We cannot call this an expression only because we have the equal to sign. We call it the equation. V equals to R into I. Now the questions on Ohm's law and the further flow depends on what all can we derive from this equation, what all can we infer, what all this simple equation implies. And that's all. Like, this is basically the Ohm's law. In the end of the video, I'll show you the statement of the Ohm's law, and that's the end of Ohm's law. But I also try to do a question so that for better understanding. Like I said, now it all depends on what all can be inferred from this equation. So now we go on introducing little transfers and little manipulations, not manipulations at all, little shifting in this equation. If it equals to V equals to R into I, we write V by I equals to R, resistance, which is constant. Why constant? In this, first of all, it has been introduced as a proportionality constant. It is very obvious that it is going to be constant. Simple. At least and as long as it's the wires, length, area of cross section, it's the temperature. The first phrase in the Ohm's law is that at constant temperature. The resistance will also be constant. if you change the temperature, if you change the length of the wire, if you change the area of cross section of the resistance will change. And we'll get to more about resistance in the next videos, or maybe let's see when I get into resistance. But for now we are concentrating on the Ohm's law. Constant. So basically, potential difference upon the current will be constant. That is the first thing that we can see from here, and we also see this in the questions. Basically, that is equal to the resistance. Just a way of putting things. We could have also skipped this thing, just to tell you. Next, we show inverse proportionality. See. Now that we have this first shift we did here, we found R equals to this, and that's what we saw, that's going to be constant. Now what we do, we do this. We transfer R this side, R to the denominator, and keep I as it is. Now we get another meaning. What we get is, we from here see that current is directly proportional to the potential difference because they are both in the numerator, and current is inversely proportional to resistance. This is only the sign of proportionality. We show direct proportionality or inverse proportionality based on where we keep it, where we keep the subject. We keep it in the numerator, it is direct proportionality. It's the denominator, it's inverse proportionality, inversely proportional to resistance. So now what does this thing here mean? This means that if current is doubled, the voltage will be doubled. Basically, if the voltage is doubled, that's the proper way to say it, the current will be doubled. If the resistance is doubled, the current will be halved. That is the implication of this, and this is one of the most used. This is never going to be, this is obvious, this is a very obvious thing. Leave that thing. Look at this thing. These things are one of the most used in the simple and basic questions. Otherwise there are going to be no questions at all. We look at a very simple question here. You should note this question or remember this question. I will remove the question now. Read it fast one more time if you want. That an iron draws a current of 5 ampere. Let's call it I1. I1 when of 5 ampere, when V1 equals to 220 volts. The question now is, what will be the I2 when the V2 is equal to 110 volts. Now see the question here. The first we got from this was V equals to Ri. We got V by I equals to R, and we also saw that it is going to be constant because that's a proportionality constant. Okay, till the temperature is equal and all the other parameters I mentioned earlier, R equals to constant. Now see how we use it. This only means that for a particular conductor, R is going to be constant no matter what is the voltage, no matter what is the current. R is going to be constant, and that is the only missing link between these two different datas in different situations, there is the only missing link. That is the R. It's the missing link, and that is how we get this thing. We use this thing that for a particular conductor, full stop, R is going to be constant no matter what the values of these things are. So we see from here V1 equals to I1 into R, no 1 auto required. R equals to 220 by 5 minus 20. We are dividing 220 by 5 minus 20, 2 again 20 minus 20, so it's going to be 44. So R is equal to 44 ohms is equal to R. Now we want the I2. Now that's going to be very simple, because V2 equals to R into I2. V2 equals to 110 equals to 44 into I2, and now I2 equals to 110 by 44. Now 11 tens are and 11 fours are 10 by 4, also equal to 2.5 ampere. Hope so, man. This is 2.5. Yes, 2.5 amperes. So that is the simple and basic use of Ohm's law. Thank you.